Well, thank you very much. It's great to be here. It's great to be back in Ann Arbor and in this lovely hall. I had forgotten how beautiful this room is. So thank you for coming. Let me try to do a bridge between just a fantastic summary of the successes that you're enjoying here at Michigan and my remarks. I'm going to talk at a much higher level of abstraction. It is a talk that is motivated by the concerns of the little frog pond that I live in and that others in this room live in the social sciences, where we have been part of an inferential paradigm of how we make decisions about what we know about large populations, finite in size, but large nonetheless, and how so-called big data and the characteristics of that original paradigm are in need of one another. And I'll end with some comments about how I think we need a new institution in this country and probably in other countries in order to facilitate the movement between the existing paradigm and the future. So this is a rough outline. I want to give everybody a common background of how nation states have kept track of themselves over the past few decades. Talk a little about features of big data, which I label here organic data, that are interesting and perplexing and puzzling and challenging, and then raise an issue that comes as quite second nature to many empirical social scientists. That is, how do we know, how do we discern the quality of data and the quality of statistics arising from them? And then I'll talk about what I believe is the next step, and that is blending together data sources for the future. So let me just note first that every nation state that I know of has created over its time a set of agencies whose job it is to monitor the social and economic status of the society. These agencies tend to be quasi-independent, especially in democracies. A desirable feature is that they cannot be influenced by who's in power at the particular moment. And the kind of indicators that you see on this slide are common across nation states. Those statistics heavily depend on something we call the sample survey, which has various ingredients to it that are well honed over the decades. There's some unique attributes of this paradigm. The researcher controls the measurement. Data are not merely acquired, they are designed and collected anew. And that's a very important part. You're in control of the data. And the data are small relative to the kind of data sets we're talking now in terms of numbers of observations, numbers of units of measurement, if you will. But they're gloriously multivariate in terms of the number of attributes measured on those units. Those multivariables have been designed for purpose in mind. And then there's a pretty tight inferential paradigm going from the data set to some target population that you're interested in describing. And there's great concern about missingness at that moment of inference. What have we not observed on the sample that we have drawn that may interfere with that inference? And then also on measurement properties. What do we know about weaknesses of the measures that would interfere in the measurement? And so it's a tight set of steps of measurement. I go, really we're interested in our inference in some target population. So for the US government statistical agencies, this is sometimes the population of all US economic units, establishment enterprises. Sometimes it's the population of US households. That's what we're really interested in. But actually, we have a data set that's a set of respondents. They are respondents from some well-defined sample, generally with known probabilities of selection. And that itself is a problematic step. And usually that's through a set of model-based adjustments. And then we rely on another inferential step to a list or list-like function of the entire population. And probability theory allows us to make this inferential leap. And then generally there are problems between this thing called the frame. For example, in US political polling, Al was talking about that, I think. We often deliberately miss large segments of the population from the list from which the sample is drawn because they are not connected to the medium that we use for measurement, either the web or landline phones and so on. And then there's another adjustment step. So what do we know about this paradigm? One, we have strong inferential properties. We think we know about this inferential step. Two, the data that have been collected through this process are often publicly available. And in a democracy, that's a nice thing, right? Anyone could check on whether the statistics put out by the central government are correct. That's a nice transparency property. The temporal and spatial granularity and ability to drill down to subpopulations are weak. Why are they weak in this paradigm? Sample sizes are smaller than one would like in time, in space, and in subpopulation. Why are they small? It's expensive to do this original measurement. And then on measurement extension, it's strong. That's the multivariate nature. On network characteristics, something that we've been totally engulfed in with many social media data sources, these data sets are quite weak. Networks are not measured there. And so there are a whole set of questions, as it turns out, from government statistics that are unanswerable from these data sets because we can't measure the influence of networks. So what's wrong? What's happening to sample surveys right now? The rate of participation in surveys and censuses in all the developed countries of the world are declining. For those agencies that care about complete measurement of a probability sample of a large population, they make more and more efforts to increase that participation rate. The greater number of efforts increases costs. So it is literally true that there are fewer new government surveys being created in this country than ever in my lifetime. It is true that there are surveys that have been dropped for cost reasons. So to overstate the case, it is almost true that we know less about the US economy and the society than we did 20 years ago. This is a bad state of affairs. So I've used these terms design data to describe that sample survey paradigm. Remember what I said? You don't just acquire data in this paradigm, you design it and you measure it and you produce it from so-called a term that I'm using on organic data, which is mainly the kind of big data things that data scientists are talking about. I want to make that distinction because it has implications for how use of data must be governed. So the kind of organic data are the ones that you know and love, and it's now clear to me from listening to the earlier talks that somebody in Ann Arbor is dealing with these data, I'm now convinced, for some of the work in the data science initiative, and that's wonderful. But what do we know about this stuff? If these circles were the rough volume of digital data in 1960, I'm asserting here that the data acquired and known outside of the organic data was much larger, and by 2010 it's bigger, and if we believe McKinsey-like studies, that blue circle is increasing at a rate of 40% a year, right? So in your 50-year anniversary of the Data Science Initiative, you will not be able to see the government statistics points if we keep going at this rate. And these are things you know. Credit card data, fairly structured, interesting data set if you're a microeconomist interested in consumer behavior. Mobile devices, you've gone through those. All the stuff on social media, which can be obtained to study both behavior as well as network impacts. And then the Internet of Things, which is blossoming at a rate that we can't even keep track of. The speculation here is by 2020, we'll have 50 billion devices on the grid spewing out data about what they're doing. And what that means for us is not at all clear, as I hope to make the point, because we don't know who will control those data and whether folks like us in this room will have access to do the kind of work that we believe is making a better world. So what are the common features of all these data sources? They're behavioral measures, I think. They're not certainly measures of internalized states. So the reference to political polling, those design data from those surveys were attempting to acquire an internalized state, an attitude, a sentiment, if you will, towards a political candidate. So it's very rare that direct measures of sentiment will be controlled out of these big data sources, and that's an important thing. The second thing is the temporal granularity is just overwhelmingly cool. You know, you can really imagine, instead of doing gross domestic product yearly or quarterly, or the consumer price index monthly, that we could have second by second computer price indices, right? It is conceivable that you could acquire such a set of measures. The question is, would we know how to use them if we had them? That I don't know. That we can do something like this is now increasingly being clear. The third thing is, there's not all good news here. These data sources tend to be lean in a multivariate sense. There are not many variables on each observation. And this portends, I believe, and I assert that the future has to be blending these data sets together, right? We want multivariate models. We want to understand how large sets of variables hang together or don't. The only way to do that in this new world is by blending data together. And then, unfortunately, a lot of these data sources are created to run something. They're not thinking of us as researchers when the data are created. And those of you who played with these data know that the enterprises that construct these are quite happy to change the definition of a variable on a whim if their processes are benefited by that change. And the notion that they'd have to document that change for a downstream researcher is something that they're not particularly worried about. So the metadata side on this is tough. Temporal inconsistency is tough, which means there'll be a rebirth, as is clear from your slides, of attention to quality of data, anomalies, inconsistencies. And then the last bullet is the bullet that my crowd, my tribe, cries about all the time, vociferously. So I have a friend who analyzes Facebook data. And he says, I said, well, how do you get around the inference problem? You know, not everybody's on Facebook. And he said, but I have billions of observations. I said, but you know, there's 7 billion people in the world. If you're interested in the world, aren't you concerned about that? But I have billions of observations. So there's a clash of inferential cultures here. Statistics based on a whole lot of observations are cool when you know the properties of the pool of the observation. What can be observed, what cannot be observed. And if you reflect back on the paradigm that we talked through at the beginning, you know, from my frog pond, this is a big deal to worry about that inferential step, to worry about who can be covered by the measurement process, who is not covered, who can be measured, who cannot be measured. And so those are weaknesses and strengths that end up producing a chart like this relative to the survey paradigm. Weak on inference to well-defined populations. That is rigorously well-defined populations. Weak on open access, and here I haven't really motivated this, I will in a minute. Really cool on temporal granularity generally, and often on spatial and subpopulation, depending on what kind of identifiers and tags you can put on it. Weak on multivariate measurement. So if you paired up this slide with the earlier slide on strengths of the sample survey paradigm, you quickly come to the conclusion, gee, if we put these two things together, would the world be better off in some way? And that's the assertion. So the assertion that I'm making is that the future of government statistics around the world is not its past. And it is also not just junk all of the surveys that have been carefully designed over the decades and replace them with big data. That won't work either. We need to blend these sources together. The coin of the realm in this blending will be overlaps of measures, some shared covariates, and probably a redesign of the sample surveys to permit that marriage, right? As simple as knowing if you were blending social media data, say Twitter data, with a sample survey source, asking the survey respondents whether they are Twitter subscribers and how many tweets they emit per time unit. Why would you ever want to do that? Well, that allows some covariance shared between the two sources of data. Now, there's another problem, and that's on the quality side. This is a paradigm that many of us have used for some time, thinking through the quality aspects of sample survey data. On the left is a measurement inferential step. On the right is a representational inferential step. The right is all about designing and drawing a strong probability sample from a well-understood sampling frame in order to draw inference to a target population. On the left is that measurement design step. Careful understanding of how we can create a de novo measurement in order to tap into some construct, some attribute of a sample unit and generate a response from that unit in reaction to a stimulus that is standardized. The stimulus is a question often in a survey interview. The response is the answer of the respondent. And the ellipses here are all of the quality features of this dual inferential step. That left side is absent many times when you acquire existing data, existing big data. You are not privy to that left side. It's a black box many times. And hence, if we're going to blend sample survey data with organic data, we somehow have to grapple with the quality characteristics. And I think by and large, many of these quality characteristics will survive their application in the big data world. But there are a few things that I find kind of interesting and perplexing on how to apply those. And there are four, and I'll give you little examples. One is that some of the data we're dealing with are generated by a process whose stimulus we have no idea about. It's really a black box. Why do we possess this data, this datum? Secondly, sometimes the process of generating them is unknown. Thirdly, some of the organic data, and this is really cool if you're a statistician, could come with measures of error of the observation itself. And I'll give you an example of that. And that makes statisticians start to drool. And then finally, there's a particular problem of organic data from text that a bunch of people are working on. So first, no measurement stimulus. Think of a tweet for a minute or a blog. On the left is what survey researchers do. They spend a whole lot of time designing measures. On the right, let's say we have Twitter data and we have a tweet. But there are a whole lot of subscribers who chose not to tweet at that time, on that topic, whatever. This stimulus to tweet, not tweet, is unobservable in most cases. So why did I choose to send out a tweet about Donald Trump on Wednesday? What was that? And why did a friend of mine who shares all of the attributes of mine choose not to send out a tweet? We don't know. We know this, and we can do all of this stuff. We know how to do that stuff well. But in contrast to the survey paradigm, where you know the stimulus that created the datum, we don't know the stimulus that created that, and that's a problem. Sometimes the measurement itself that generates the data is the result of an earlier process that is affected by the attributes of the people. So imagine you're on a web page, and to the right are a bunch of ads that pop up when you hit the web page. And let's say I'm interested in the click rate on those ads as a measure of your interest in the product. So then we have to say, what was the stimulus that created the attribute that we're using as a data item? Well, your ads are going to be different than my ads. Why is that? Well, they're predictive analytics that produce the ads displayed. Are the predictive analytics that produce those ads displayed on my page known? So when I know that I clicked or I didn't click, what do I know about the likelihood that the stimulus that created the behavior that I'm using in the data is known or unknown? What do I know about that? That's a problem in terms of the quality of those kinds of data. This is a case where the data item is generated by a process that itself is the result of a model personalized to the respondent. Treating those data, those click rates, without knowing the propensity of being of the display of different ads is an error, probably. And then finally, or next to last, I guess, some of the data that will be analyzed will be the results of models themselves in a way that will get some insight into the uncertainty of the models that produce the data. And so examples here are mainly based on visual data. And so let's say I'm trying to do some facial recognition. If you look at this literature, you know that this is model-based prediction, match rates. The models themselves come with error bars attached to them. So here's a data item that comes along with a measurement error on the data itself. And this is a fantastic part of the future. If we had the same thing on the add display data item, we'd be in better shape, but we don't. And then finally, unstructured data, especially text data, for a survey researcher, brings us back to a time when I first entered the field 400 years ago. And believe it or not, at that time, an interviewer would knock on your door if you were a sample address, and you would invite this person in because in those days you invited someone in. And that person would sit down for about an hour and ask you questions and write down verbatim your answers. And then in the Institute for Social Research on Thompson, we employed hundreds of people who read those words, word for word, and classified the words into a category, and we assigned a numeric code to the category, and we had empirical data, right? That was the process. Well, we're gonna go back to the future in a way, but we know a lot more about computational linguistics. We know a lot about word structure, but we'll never get around things like this, right? So this is the word back, and this is contextual meaning of the word back, just for fun. The humans that read these words quite easily changed the meaning of the word back to fit the context of the sentence. We'll need algorithms, and people are doing this actively, to be more and more sensitive to that. We will recreate those human coders who used to be in Thompson Street reading these words. So I said I think we need a future of blending. This will be a lifeblood of statistical modelers. If the future is bright in any subfield, it's one for complex models that blend together data. I said already that shared covariates have got to be part of this. But these models won't, I think it's now clear to me, these models will not be based on deterministic micro-level matches at the unit level. Say you're interested in people. It seems unlikely that we will build very, very large data sets that will add variables by deterministic micro-linking at a person level to do our analysis. It's going to be more complicated than that. It will be probably a nesting when we don't know who the person is that emitted the data item, but we know roughly where they live or when they did it. Then we'll build models where the shared covariates are either space or time. I think when we do this, there will be also another subfield that will arise in a big way. After we get through this fury of use of big data without being thoughtful about their quality, there will be an emergence of a field of data quality experts on this that will win the day. So if there's anyone in the room who's between 20 and 30 years old, that's where I'd bet. Bet for quality and inferential limitations, measures of uncertainty, measures of bias, because that's where we're going to end up, in my belief. So this is a horrible blended paradigm, right? This is just, it is much more complicated. I'm imagining that I'm back to government statistics. We're worried about the US population. We do have frames, lists of addresses, spatial units that we attach people to in the country. It's pretty good. And we draw samples from that frame and we interview people. But as I said, this leap is getting more and more problematic, and these sizes in terms of samples are getting smaller and smaller, and we got to bring in these sorts of things. That's a much more complicated world of government statistics, but I think that's where we're going. So what do we have to do to build that? The talks at the beginning were great in that they warmed my heart in the belief that the future has to be a much more transparent future. It has to be deeply sensitive to privacy issues. That can close down our enterprises faster than one could ever imagine. We have to, out of this complicated data structure, create still pretty simple statistics, right? We need to communicate to a population that will not be, will not understand the complexity of that, but we need transparency and simplicity at the same time. And then this third point, I feel strongly, we have to make sure the science wins out on this, that we provide information to the society, but we also are very explicit about the uncertainty of our estimates. And that's going to require a whole lot of sensitivity analysis of our work. It's really a new culture of estimation, I believe. So what's the problem here? In contrast to the world of 1960, when most of the digital data were held by government agencies or academic agencies, most of the data now are held by private sector firms. Their missions are not to provide information for common good purposes. You can't make a lot of money doing this, believe me. They have a different mission, but they hold these data. So the blending requires access to those data. And post-Snowden in the United States, the notion that these private sector firms would happily give these data to the government seems tenuous at best. And so I think we need a new institution that doesn't exist. It can't just be a research institution in my mind. It has to be oriented to direct common good information products, and it's going to require massive data sharing. The impediments here are clear. There are distinct cultures between government statistics and these private firms. There are legal barriers for real partnerships. The federal agencies can't acquire data and share them back in a transparent way. There are all sorts of unclear quid pro quo. So why would a private sector firm want to do this? What's in it for them has to be answered. I think there are some answers there. And then all of us are increasingly concerned about privacy protection. How to do that practically in a world where you cannot anticipate how data might be used in the future is a hard thing. Here are some of the ingredients, I think, that are answers to those questions. Some of them, I think, will require legislative changes. Some of them may require tax incentives for the firms. There are three things going on now that makes me hopeful. I think there are small odds that this will ever happen in this country, but the odds are higher than they've ever been in my lifetime. One is that there's a panel pecking away at the National Academy of Sciences, some members of whom are in the room, that are looking at both the access and the technical problems of blending together multiple data sets for common good purposes. There's a new commission that Paul Ryan and Patty Murray collaborated on, a Democrat-Republican collaboration, a signed law that's created a commission on evidence-based policy. The issue in front of the commission is precisely the same thing. How do we start sharing data across large agencies and organizations that are not now used to sharing for common good purposes? And then at least three foundations have awakened and say, this is a moment where we could really build a better data world for the United States if we can conquer these impediments. All of these activities are going to culminate in a set of stuff in fall of 2017. They all hit at the same time. They'll all be kind of Washington-based things. And so that will be the moment where if we collectively get together and say, now is the time to build a new institution for common good purposes, we might have a shot at that. So I've done what I wanted to do. I'm happy to be here, and I'm thrilled at what's going on at Michigan in data science. I congratulate all of you for your work. Thank you.
Because we are based in China, we are actually very interested using big data approach to do artificial intelligence, in particular Chinese language understanding. That's a very key aspect.